On a restless and violent planet, life has fought for survival for billions of years. Only winners leave descendants in a ruthless and costly battle. On the tree of life are many dead branches. Whole armies are now extinct, known only by their fossils. Today's animals are the few survivors of a 4-billion-year war. Against incredible odds, many have dodged disaster again and again. Can the secrets of these ultimate survivors help to predict the future winners in the triumph of life? This could be a scene from today, but it's the Cretaceous period, 65 million years ago. In this distant age, many animals look familiar. Some creatures are very different. But evolution is shaping life in exactly the same way. Animals are exploiting each other, trying to get ahead. In this survival game, the rules are always the same, only the players change. But long-term success depends on the ability to cope with the unexpected. A catastrophe like this could happen again. But whenever life stumbles, other life steps in and seizes the chance to triumph. After the dinosaurs' extinction, small furry survivors would inherit the Earth and give rise to every mammal we know today, including ourselves. A mass extinction has always been followed by a time of enormous opportunity for the survivors. Dinosaur bones had hardly started gathering moss when mammals began building a new dynasty. Many were small insect-eating animals, rather like the tree shrews of today. For millions of years they had lived in the shadow of the dinosaurs, hiding under the cover of night. With the giant reptiles extinct, they emerged into the day and flourished. Usually, evolution works at a snail's pace, but after a mass extinction, the process goes into overdrive, filling the vacuum left by all the animals that disappeared. The resourceful mammals were quick to take advantage of new opportunities. By coincidence, flowering plants were also on the rise. The mammals soon discovered novel foods like nectar, pollinating insects, and fruit. The furry pioneers began to specialize as they carved up the new world between them. Today, the mammals fill all the roles once held by the giant reptiles. Giraffes specialize in reaching the treetops, just as sauropods once did. And big cats tear up large prey, following in the footsteps of tyrannosaurs. The dinosaur extinction should be dear to our hearts. It gave the mammals a chance to take center stage, and that made our own evolution possible. The history of life is like a tree in early spring. At the tips of the branches are green shoots, representing species alive today. But these are a tiny fraction of the tree's history. A journey back in time travels down the branches that led to today's creatures. Below are the boughs and sturdy trunk that represent animals long gone. Mass extinctions are like storms, stripping most of the leaves from the tree. Most of the species that have ever lived are now extinct. The story of life is also the story of extinction. Some places look as though they've been lifeless for an eternity, but the rocks tell a different story. Here and there, the forces of erosion open windows onto the past. Today, only fossils tell us that dinosaurs ever existed. Most of life's secrets are still hidden in the rocks. Each step down the strata is a step back in time. Here and there we see snapshots of past worlds now long gone. The conditions needed for a fossil to form are rare, so only occasionally do these rocks hold a glimpse of our planet's life story. Some chapters are missing altogether, but where fossils are abundant, we can piece together the world of that time. "200 million years ago, the rocks preserved rare insight into the story of one large extinction. This was the time of the clams. Their watery homes buffered them from the fires that raged on land, and their shells protected them from early predators. For millions of years, their world changed little. So neither did they. The clam's simple design had been a huge success. Yet they were heading for disaster. A new generation of predators with superior weaponry invaded the clam's world. The crustacean claw had arrived. The claw was a huge advance in shell-smashing technology. Until then, thin shells had provided ample protection, but predation had just shifted gear. The crustaceans caused carnage on the sea floor, but their claws were just the first blow. For the clams, the next deadly innovation was closer to home. Carnivorous snails, relatives of the clams, evolved a tongue like a drill. This rasping tool could grind through the toughest shells. Once the clam's defenses were breached, the killer snails sucked out their prey's innards through the drill hole. Now, the clams were under siege. A third blow came from fish. Sharks had been around for millions of years and were no threat to the clams. But from sharks came a new generation of specialist shellbusters, the skates and rays. These clam killers had bodies flattened for life on the seabed and powerful jaws that could easily crunch through fragile shell. Before this predatory assault, clams had covered the seafloor around the world, but now their numbers collapsed. This was the end of an era. Clams either shaped up or faced extinction. Clams hadn't changed in millions of years, but a few kinds were able to adapt quickly and avoided extinction. Some escaped by burrowing out of reach. Others, like the mussels, fled to the edge of the sea, taking advantage of the tides to leave their old enemies behind. Some clams have removed themselves from the fray completely. Coquinas stay in shallow water. They move up and down the beach, tracking the surf line. By living at the very edge of the sea, coquinas dodge predators from both ocean and land. It's a marginal existence, but this adaptation saved them from extinction. If adaptability is the secret of success, why have some ancient creatures never changed? The aardvark is a design classic. It has outlived most of the early mammals, but is virtually identical to those first aardvarks preserved in the fossil record. Aardvarks eat ants and termites, and for 70 million years, they've hunted nothing else. Valves in the nose keep out soil. Powerful claws make light work of digging. And upside-down eyelashes deflect upward flying dirt. Aardvarks are totally specialized for eating termites. Tiny termites seem a strange choice of food for a large mammal, but they are the aardvark's survival secret. These insects have been reliably numerous for hundreds of millions of years, giving termite eaters the ultimate in job security. Aardvarks can even break into termite mounds. Their huge claws smash through rock-hard mud with ease. termites do fight back, squirting caustic chemicals at the intruder. But the aardvark is rarely deterred. And the longer the predator stays, the more termites rise from the depths and swarm over the intruder, but to no effect. The aardvark is now so specialized that it couldn't eat anything else. Because it laps up termites through a tubular snout, the aardvark has lost its front teeth. This would prevent it changing diet if termites ever vanished. The aardvark needs enormous claws and sturdy limbs, but these would be too clumsy for chasing larger prey. This specialist will never be a flexible creature, and yet its future looks secure. The long-term survival of any predator is usually linked to its prey, and there will likely be plenty of termites for aardvarks. Other specialists are more vulnerable. The cheetah is a dedicated gazelle killer. But the cat's extreme speed comes at a cost: reduced bulk and strength. It can no longer kill with brute force. It can trip a gazelle, but this tactic works with few other animals. Its jaws fit perfectly around a gazelle's windpipe, but don't have the power to choke other prey. The cheetah's genes for swift hunting will pass to its young, giving them an edge during their lifetime. But specializations that help an individual cheetah are handicapping the long-term survival of the cheetah line. The African plains seem full of prey for big cats, but a cheetah is now very short of options. Having sacrificed brawn for speed to catch gazelles, most of the other wildlife is now beyond its reach. The cheetah is not even strong enough to guarantee protection for its cubs. Every year, large numbers are lost to slower but more powerful lions. This spirited attempt to distract the lion has worked, but it will be many months before the cubs are out of danger. The unspecialized hyena, often a scavenger, is easily strong enough to steal a cheetah's kill. Hyenas are opportunists and will steal prey from anything. Their teeth can crush the toughest bone. Both fresh kills and rotting carrion can be digested by their huge stomachs. Their behavior is very flexible. And they can hunt together, tackling animals a single hyena could never manage. Hyenas are versatile animals with a bright future. Unlike cheetahs, these elegant cats are so reliant on gazelles that if their prey ever went extinct or evolved a way of outrunning them, cheetahs would soon disappear. As the fastest land animal, the cheetah may be a pinnacle of evolution. But ironically, its success may be short-lived, like many specialists before it. Nowhere is the triumph of flexible behavior more dramatically seen than on the barren island of Espanola in the Galapagos. Mockingbirds share this harsh shoreline with seabird colonies. They live by opening seeds with a sharp, powerful beak. The first mockingbirds to arrive would have faced difficulties. Seeds can be scarce, but the biggest challenge was to find enough fresh water. Seabirds get water from their fish diet, but the mockingbirds had to find other ways to get liquid. Their flexible behavior led them to investigate abandoned eggs. But the supply of eggs is highly seasonal, and there aren't enough to go around. Marine iguanas are common on this island, and mockingbirds often clean parasites from their skin. Removing ticks can spill small amounts of blood, and this perhaps led these birds to discover a new fluid. The mockingbirds of Espanola have become vampires. A beak evolved for seed eating seems ready-made for this new role. With no freshwater pools, this island should support very few mockingbirds, but their opportunistic approach to finding fluid has solved their biggest problem in this difficult environment. Today, they only enlarge existing wounds, but they may be just a step away from attacking undamaged flesh and opening up new opportunities for blood-sucking. These mockingbirds may be the founders of a new dynasty of avian vampires. Mockingbirds have used their resourceful behavior to conquer a challenging environment. They share this ability with an ancient survivor. Crocodiles were successful long before the dinosaurs. Since they first appeared, millions of other animals have come and gone. So why have these prehistoric reptiles hardly changed? To start with, crocodiles are not picky eaters and will take anything they can catch, regardless of size. Crocodiles are also widespread. If they die out in one corner of the globe, they can recolonize from another. Their ability to live in water gave them a retreat which has buffered them from fires and storms to this day. Protection from the elements has ensured the survival of many animals on a planet that's always changing. For over 4 billion years, the Earth has been reshaped by the extreme physical forces battering its surface. During this vast stretch of time, the same violent forces have taken their toll on life. At times, conditions on Earth became so severe that life was virtually snuffed out altogether. Five mass extinctions have struck in the planet's long history, but the greatest die-off of all was 250 million years ago, in an age known as the Permian. This was a time of great upheaval in the Earth's crust. The planet was shaken to its core. Poisonous gases filled the atmosphere, trapping the sun's rays and sending temperatures soaring. Seas and lakes stagnated and began to dry out. Many creatures from that early time, such as brachiopods and clams, were left high and dry, as seas and lakes gave way to salt pans and scorched earth. The scale of the loss is hard to imagine, and many of life's branches died forever. But somehow, survivors pulled through. Among them were two lines of reptiles. One line gave rise to the dinosaurs, the other to an animal still alive today on an island near New Zealand. The Tuatara outlived the dinosaurs, but was driven nearly to extinction by the rise of the mammals. Remarkably, no mammals have ever reached this island, and the Tuatara continues its outdated way of life today. They'd never be able to compete with modern animals from the mainland. Theirs is life lived in the slow lane. Occasionally, they intimidate their neighbors and settle disputes with short bursts of aggression. But these quickly leave them exhausted. The outmoded Tuatara will never be abundant again. And if mainland predators ever breach this island's natural defenses, history suggests the outcome would be catastrophic. 3 million years ago, such an invasion happened on the once separate continents of North and South America. The Earth's crust was on the move, and the two islands drifted towards each other on a lake of molten rock. As the gap closed, the seafloor folded, pushing up the Isthmus of Panama. Animals that had evolved apart now came face to face in an epic battle for survival. Armadillos, anteaters, and possums moved north. Pushing south went bears, wild dogs, and cats. Moving into the jungles of South America, these deadly cats gave rise to many variations still found today. From spotted cats to jaguars and jaguarundis, cats changed the face of predation in South America. Before long, animals like ocelots were hunting the jungles. Unlike the native marsupial predators, these cats could tackle anything. Their speed, power, and flexibility were light years ahead of their rivals. And much of the South American fauna was hunted to extinction. The South's native predators would have looked much like this quoll. They were less efficient hunters than the cats, but this was only part of their problem. Their forests were invaded by new prey they couldn't catch. The new wave of North American rodents were tricky customers. But the cats had evolved to hunt them. In the end, animals from the north proved too strong for their southern counterparts. Although there were casualties on both sides, the animals from the south took the greater beating. "3 million years later, a huge bird would be the first victim in a new wave of island extinctions. This time, drifting continents were not to blame. The culprit would be man. The dodo was flightless. Mauritius had no natural predators, and the bird's ancestors lost the ability to fly as they became specialized to live and hunt on the ground. The bird was ill-prepared to defend itself against new arrivals. Dutch sailors began visiting Mauritius to stock their larders for long voyages. They also brought monkeys and pigs with them, animals that would play a big part in the dodo's downfall. When the sailors first arrived, the dodos were sitting ducks. Even when they learned to run, they were no match for human hunters. Although sailors ate many dodos and stocked their ships with large numbers, they didn't drive the dodo to extinction. It was the monkeys and pigs they brought with them. The dodo only laid a single egg and grew slowly. Against these introduced predators, they were indeed as dead as dodos. Alien invaders have been driving native animals to extinction at an ever-increasing rate, and island creatures are still the most at risk. This is Guam, a remote island in the mid-Pacific. Its rocky coastline and tall cliffs once made a protective fortress for its native wildlife. But the arrival of modern transportation shattered Guam's isolation. Animals can now cross the globe in a single day. Journeys that once took millions of years can be made in hours. In the 1940s, some animals made a journey that would change the island of Guam forever. A ship from New Guinea carried some dangerous stowaways. Brown tree snakes. These predators were efficient killers in their homeland, but on Guam, they would prove even deadlier. The snakes' nocturnal habits allowed them to go unnoticed for a while. But every morning revealed their deadly toll on Guam's wildlife. Birds, like this rail, began to disappear. They had evolved on an island free from predators, and the invaders sent their numbers tumbling. While people searched for a culprit, the predators were holed up, waiting for nightfall. Under cover of darkness, the snakes spread across Guam like a wave of death, leaving a trail of destruction in their wake. The demands of hunting wary prey at home in New Guinea had left the brown tree snake a highly accomplished bird hunter. For this snake, even Guam's tree nesting birds were easy targets. The ground-dwelling rail had no chance. Like the dodo on Mauritius, the rail is flightless and often leaves its eggs unattended on the ground. Today, the rail has become another island bird threatened with extinction. As the snake's numbers climbed, bird populations collapsed. For Guam's wildlife, the snake's calling card was a symbol of disaster. Insect numbers boomed, their populations no longer held in check by birds. Spiders also benefited, and Guam's forests are often choked with webs. Now the balance of nature has changed. Island animals have always been vulnerable to extinction. But today, islands aren't only found at sea. The Amazon rainforest in Brazil, still home to more species than anywhere else on Earth. But each year, its area is reduced by logging, and perhaps more significantly, the forest is being fragmented into a series of islands. But are animals living on these islands more likely to become extinct? Loggers were asked to spare patches of rainforest for an experiment. Scientists cataloged the plants and animals living in them, then waited to see what would happen to the island's diversity of life. Out in the open, the earth soon became eroded and scorched, trapping animals in their islands. But how were these animals surviving? Signs of decay were everywhere. Trees near the edge of plots were dying, killed by the light and dry winds that could now penetrate. Many insects were gone, along with the birds that ate them. Without monkeys, the canopy fell silent. Spider monkeys needed plenty of forest to find enough fruit. Being tree dwellers, they could not cross the scorched open ground to the next patch of forest, and starved. Without the monkeys, uneaten fruits rotted, leaving their seeds undispersed. No young seedlings would replace older trees as they died. Many of these extinctions were predictable, but some resulted from a domino effect, as the loss of one animal knocked down others. It isn't obvious that a pig would be responsible for the fate of a frog. Yet peccaries make wallows by scouring out puddles in wet areas, and many creatures rely on these ponds to breed. This is a striped monkey frog. It lays its eggs in trees overhanging wallows. The most vulnerable early stages are spent developing in the relative safety of the canopy. When the time comes to hatch, they all leave together, cascading on a mucus slide into the wallow, ready for their big change into froglets. But peccaries are large social animals. To find enough food to support a whole group, they range great distances. Confined to a small island of forest, they starve. Without the action of peccaries to keep them full of water, wallows dry out and fill with leaves. With the wallows gone, many frogs have nowhere to breed, and another domino is knocked down. The frogs disappear. Most of these extinctions happen because smaller areas of forest held smaller populations, less able to bounce back from disaster. At the start of the new millennium, Earth's forests had been reduced to 1/10 of their former area. Results from this experiment suggest that half of the species they once held have already been lost. This is extinction on the same scale and at a similar rate as the one which wiped out the dinosaurs. It is the beginning of our planet's 6th mass extinction. As before, when faced with disaster, specialists will be more vulnerable than other animals. In China, pandas are incredibly picky about their food. Eating bamboo is about the only thing they do, but curiously, they aren't very good at it. The panda can harvest bamboo quickly, thanks to a specialized thumb for gripping leaves. But its intestines are not good at digesting plant matter, and most of it passes straight through. With their inefficient digestion, pandas need huge quantities of bamboo. This has become their biggest problem. Stands of bamboo go through natural cycles of death and regeneration. When one stand dies off, the panda migrates to a new one. Now that pandas are trapped in small islands of forest, when their local bamboo dies, they have nowhere to go. They starve. If only the panda could leave its bamboo island or find new food on this rapidly changing planet. But the panda is not that kind of animal. The black bear in North America is a close relative of the panda and has a similar digestion. But unlike its bamboo-fixated cousin, this bear eats almost anything. Black bears are amazingly resourceful in their relentless quest for worms, grubs, and ants. Although black bears evolved from the same ancestral stock as pandas, their flexible behavior gives them an enormous edge in the survival game. Most of the bear's original forest has been cut down or fragmented into islands. Yet there are as many black bears now as there were when the first white settlers arrived. Similar changes that spell disaster for the panda in China spell opportunity for the resourceful black bear. Many modern bears have almost given up on wild foods and hang out at dumps, waiting for fresh deliveries. With this constant supply of high-energy junk food, they put on weight, which allows them to have more young. It is the black bear's flexibility at food finding that has inevitably brought them out of the forest to scavenge. Bears are showing the flexibility of true survivors, but their long-term success is not guaranteed. Their future will depend on us tolerating their habits. If we continue to do so, the black bear should survive this sixth extinction. Our world is rapidly changing. Yet again, a storm is threatening the tree of life. This time, a storm of our own creation. And many leaves will fall into extinction. History suggests life recovers. Life's future will depend on which branches survive and which of these flourish in the new conditions. In the past, a spectacular spring has always followed winter. But which creatures will survive the current extinction? Human technology, moving more quickly than evolution, might protect us from the rapid changes ahead. But what will become of the rest of life on Earth? For all our technology, we just don't know. The web of life is complex. We can't predict what will happen as we cut its intricate threads. We could ignore wildlife and only preserve creatures vital to our survival. But our past has always been tightly bound to the natural world. Without it, the future could be lonely and uncertain. We now have the knowledge to save much of what remains. The choice is ours. Given the slightest chance, life can bounce back. Nature has amazing powers of renewal, which emerge from the very process of evolution. Today's fabulous diversity is the result of a 4-billion-year war for survival. Out of this battle has come not only the horror, spectacle, and beauty we perceive in the world, but also life's extraordinary ability to recover from disaster. It's impossible to know what the future may hold for our planet. Life's greatest triumphs may be yet to come.